So dear students, in the previous class you have seen how to build a dense layer, which is a fully connected layer. Now in today's session we are going to see how a neural network was evolved after that. So what exactly is a neural network? So neural network, if I want to say, it is created by stacking the fully connected layers that you have learned just now. Okay, so by stacking the fully connected layers into the figure that I have just explained in fully connected layer, when you stack them together and ensure two things, ensure some of the important things. What are they? You have to ensure that the number of the output nodes of the previous layer matches the number of the input layers of the current layer. So how many number of outputs you are taking from the previous layer, that many number of inputs you should give in the current layer. One thing, that's how you are going to stack. And using that particular fundamental concept, you can stack n number of fully connected layers together and a number of layers can be created through it, which we call it as a neural network. So when you stack the basic fundamental fully connected layer using two layers as is just discussed in the previous class, when you stack them together and only keep one thing in mind, that the previous number of outputs, how many are there, that much number of inputs should be there in the current layer. If you just keep a thing of that and create keep on stacking properly, then you will create a fully connected layer. You will create a neural network. So a neural network consists of input layers, hidden layers and output layers and some hyper parameters. Okay, so why are we calling them as hidden layers? Because inside it there is so many operations, mathematical operations happening, but we are only bothered on keeping it as a black box. You want to keep it as, give some input, you have to take an output. Inside it you are not bothered much, but that is happening. So that's why the layers are called hidden. So a neural network consists of input layers, hidden layers and output layers, which directly are going to affect the models. There's the weights which are associated with the inputs, the biases that you introduce, they are all directly going to affect the model. That's why they are called as parameters of the model. But there are certain things which are going to indirectly affect your model also. Like bias can introduce flexibility, you can have a learning rate which you are using for optimization, which can slow down or improve the speed of your model. So all these are hyperparameters which are indirectly affecting your neural network. So a neural network consists of input layers, hidden layers, output layers and also some of the hyperparameters. But while designing the neural network, there are some things that you should keep in your mind, which we call them as constraints. So what are the constraints that has to be followed while you design a neural network? The first thing that you have to keep a note is the number of input nodes in the first hidden layer needs to match the actual feature length of the data. So basically the first hidden layer, if I call it as an input layer, then that input layer has to have the length, the number of the neurons should be equivalent to the length of the features of the data that you are giving to that particular layer. Then only that layer will be called as an input layer. So for the input layer, you have to match it with the number of the nodes that you are keeping in the input layer should match the actual feature length of the data. And the number of input layers in each layer will match the number of output nodes in the previous layers. Like for an example, if I am creating an input layer, suppose I am creating data has got 4, the length as 4, the number of features as 4. So in the input layer I will be using 4 nodes or 4 neurons. Okay. Now after that I can create n number of hidden layers. Suppose this is hidden layer 1, suppose this is hidden layer 2. So now I have to make sure that what is the output that is coming from this input layer? There are 4, right? So I should have a minimum of 4 here. So I should make sure that the number of input layers in each layer matches the number of output nodes in the previous layer. Okay, and then the activation function. Okay, the activation function and the number of nodes in the output layer need to be set according to the specific setting of the required output. Once you have built your so far your hidden layers based on what strategy you are applying, then you have got your output layer. Okay, so the number of the nodes in the output layer will be based upon the settings which are required for your output. For an example, if you are doing binary classification, then I think only one node is sufficient that can give you 0 and 1, right. If you are going for a furthermore classification having number of classes as 3, then you can go for 3 nodes over there, and the activation function also suitably you are going to use. If it is a binary classification, you can go for ReLU, you can go for sigmoid. If you have got more than 2 classes, then you should go for softmax activation. All that we will see when I make you study activation functions. So all these constraints actually have to be kept in mind while you are designing a neural network. Very simple layer by layer implementation I am showing you here. This is like a very simplest neural network that we are designing. So for this you require actually Keras also, which is an API over TensorFlow. Why Keras? Because since we are connecting one layer to another layer and stacking the fully connected layers to create a neural network, you require a sequential container. So that can be invoked using Keras. So I am importing inbuilt modules of layers and sequential from Keras, and then what I am doing is I am actually structuring fully connected layers together to create a neural network. So the other name of fully connected layer I told it is dense. So from layers I am calling dense layer with 256 nodes, and activation function I am taking it as ReLU, and I created here first fully connected layer. Similarly, in my next layer I am choosing out the nodes as 128, and I am creating FC2, and then 64, and as you see, as the number of hidden layers are increasing, the number of nodes will decrease. It all depends on how do you want to extract the features. Okay. So lastly, suppose if I want to go for an output layer, I have to see how many number of classes or that I am going to give as an output. Suppose I have to define 10 classes, so I am using here 10 as my node in my output layer. So here I am taking input layer, hidden layer 1, and then hidden layer 2, and then hidden layer 3, and then I am having my output layer. So you can see here as an activation function I am choosing here none, because it is a normal output that I want to come over there. So then I have to define my inputs, which I am generating randomly using normal distribution. Now what I am doing here is, first I am getting output of hidden layer 1, which I am calling H1. I am simply giving input to my first layer. So this is how it is created. X is given to the first layer FC1. Your FC1 has got 256 nodes, right. The output of it is given to the next layer. So I am calling the output of it as H1. So using this, you have actually created this particular part. Am I clear? Right. Then what you are taking H1, you are giving as an input to fully connected 2, and then what you are getting output as H2. For this I have taken 128 nodes. So this is what you have done here. So you can see here I have used H1 as an input. So next H2 is given to FC3, which is having 64 nodes. So I am taking H2, I am giving it to FC3, and then I am storing the output as H3, and then the output H3 is finally going to my output layer, which is having 10 nodes, right. So H3 is given to FC4, I'm calling the output layer here as FC4, and then what I get as an output is H4, which is my network output. So you can see that these inputs are passing throughout here sequentially one after another, creating a model like that. Thus we are creating a sequential model. So I encapsulate now a neural network through a sequential container using sequential, and in that I am going to pass these layers: hidden layer 1, hidden layer 2, hidden layer 3, and then finally I am simply building this particular model and adding input to just give me the resultant output. So thus I created an entire neural network very simply using TensorFlow and Keras. That's the beauty of TensorFlow and Keras. You don't have to do things entirely manually, it is going to do it for you. So it has got a set of predefined weights and biases. You don't have to introduce anything to it. All you are going to do is define how many nodes you are choosing, what type of activation function you want in those layers, and just give them the connections between these layers, and your model is built. You are supposed to pass the input, get the output out of it, as simple as that. So this is how you created a layer by layer model implementation of a neural network. There is one case study that I want to project it for you so that you can just work on it, find out answers for it. You design a fully connected network architecture where all activation functions, suppose they are all sigmoids, okay, and suppose you are initializing the weights with large positive numbers. Is it a good idea? You have to try and fetch an answer for it. Second thing is, suppose you are doing a full batch gradient descent using entire training set, you are not using batches, okay, and is it necessary always to shuffle the data, okay, and you explain the answer. Suppose you are going for a classifier, suppose you have got images of dogs and cats and you are going for an image classifier and you are using mini batch gradient descent as an optimizer. Now you have split your data into training, testing and validation, and the classes are balanced. Now suppose you realize that within the training set the images are ordered in such a way that all the dog images are coming first and all the cat images are coming, and suppose when that is happening, your friend tells you have to reshuffle your data before actually training procedure. Is your friend correct? Do you actually need to reshuffle the data? So all these are the little points that I want you to focus on and get an answer of it. So see you in the next class.